In a revealing announcement that could change our position in the cosmos, NASA has reported the detection of the first extraterrestrial signal coming from the direction of Proxima B, the closest known exoplanet to Earth, located just over 4 light-years away in the habitable zone of its star, Proxima Centauri. This discovery has generated a wave of excitement and curiosity worldwide. Could this be the moment when humanity discovers that it is not alone in the universe? The path to this momentous discovery began with meticulous observations by NASA's powerful telescopes, which have been monitoring distant stars and planets for signs of life. Proxima B has always been a leading candidate in the search for extraterrestrial intelligence due to its Earth-like characteristics and proximity to our solar system. The detected signal is distinctive, and unlike anything astronomers have observed before, marking a potential turning point in human history. The implications of such a discovery are profound. First, it confirms the long-standing scientific hypothesis that life could exist on other planets under Earth-like conditions. Second, and perhaps more intriguing, it raises the question of the nature of the civilizations that might reside there. Are they mere microorganisms or advanced beings possibly capable of interstellar communication and travel? This signal from Proxima B is not simply random noise or a natural cosmic phenomenon. It carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams, are now tasked with deciphering this message, attempting to understand its content and the intentions behind it. The global scientific community is abuzz with theories and speculation about the possible content of the message. A guide, a greeting, a warning, or something completely unimaginable. News of this discovery has gone beyond the boundaries of the scientific community, sparking debates on social media, in government halls, and at dinner tables around the world. People are looking up at the stars with renewed wonder, pondering the beings who might be doing the same thing on a distant world. How similar or different might their world be to our own? What would their society be like in terms of technology and culture? The possibilities seem to be as vast as the universe itself. In addition, this detection opens up a host of ethical and existential questions. How should humanity respond if the signals really are coming from intelligent beings attempting to communicate? What protocols should be established for interstellar diplomacy? And most importantly, how would such a discovery change our understanding of religion, life, and our very identity as human beings? While excitement is building, there is also palpable caution. Cutting-edge scientists at NASA and other space agencies are working diligently to validate the findings, ensuring the signal is not a false positive or misinterpretation. We are on the verge of what could be the most significant discovery in human history, so the next steps must be taken with precision and responsibility. The world awaits with anticipation a more detailed analysis. The detection of an alien signal from Proxima B not only propels our scientific efforts into a new era, but also unites us in collective curiosity and hope. We may finally be on the verge of answering one of the oldest and most profound questions. Are we alone in the universe? In April 2019, a radio signal was detected coming from outer space, specifically from the Proxima Centauri region, 4.37 light-years away from us. Although it may seem like a considerable distance, it is the closest star to the Sun, being 3 times farther away than the third brightest star in our sky. This signal comes from a triple star system composed of the binary star pair Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the 2 stellar companions, are relatively close to each other and are quite similar to the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright, with an orange hue. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is smaller, so our Sun fits exactly between them in size. But where did the signal between these stars come from? The innovative Breakthrough Listen project, dedicated to searching for extraterrestrial communication in the universe, has named this signal Breakthrough Listen Candidate 1, BLC-1. The project, which has been funded by approximately $100 million, has used thousands of hours of observation with state-of-the-art telescopes around the world. The signal was detected by the CSIRO Parkes Radio Telescope in New South Wales, Australia. This telescope was observing the region of Proxima Centauri, the closest star to our Sun. The signal almost went unnoticed among the vast volumes of data collected over thousands of hours, but scientists managed to identify it as a needle in a haystack. For the signal to be considered relevant, it must have two definite characteristics. First, it must be limited to a small range of frequencies, since such radio signals are not created by natural mechanisms in space. Second, the frequency must fluctuate according to the relative motion of the exoplanet with respect to Earth. Scientists had to analyze almost 4 million individual signals picked up by the telescope in Australia. After an exhaustive process of filtering and removing unnecessary signals, they found 5,000 distinct signals, among which one stood out. A signal that could not be explained after cross-checking with contemporary radio transmitters on Earth. This unique signal, with a narrowband technological signature, only appeared when the telescope was pointed at Proxima Centauri and was observed for a period of 30 hours. After a thorough analysis, its origin was determined to be Proxima B, an exoplanet discovered by astronomers in 2016 using the radial velocity method, which detects variations in the position of a star caused by the gravitational attraction of orbiting planets. The star will describe a small circle. Extremely sensitive spectrographs are used by researchers to follow the light of a star. The spectrum of starlight shifts slightly towards blue when it approaches a planet and towards red when it moves away from it. When these changes occur repeatedly and regularly over days, months, or years, it is accepted that the variation in light is caused by the gravitational pull of an orbiting planet. Upon closer examination, Proxima B turns out to be very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times greater, indicating that it is a rocky world with an equivalent density. However, there are significant differences. The first is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star, at just 0.05 astronomical units, while Mercury is at a distance of 0.39 astronomical units from the Sun. This proximity would make Proxima B an extremely hot planet, but since Proxima Centauri is a dim red dwarf, the planet receives only 60% of the energy that Earth receives from the Sun, placing it in the habitable zone where life could exist. There are countless unknown planets scattered throughout our universe. So far, we have discovered an impressive 4,935 exoplanets and have recently added 65 new planets to our count, bringing the total to 5,000. This latest group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever built, being 100 times more powerful than its predecessor. With its help, we will be able to unravel the secrets of this vast expanse of the universe. In the past, we have discovered a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as extremely hot and habitable planets. Among these discoveries, some planets stand out in particular. Kepler 1649c is one such planet whose characteristics are very similar to those of Earth. In fact, it is the most habitable planet we have found so far and could support life. So far, we have identified 55 Earth-like planets, but we have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially thanks to the James Webb Telescope, who knows what else we might be able to achieve in the future? Wouldn't it be amazing to find a planet capable of supporting life? One of the main objectives of the James Webb Telescope during its first year of scientific missions is to find and study alien worlds beyond our solar system, focusing on how they form and the possibility that they contain water and biological life. Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as relating our own solar system to its origins. Webb's infrared capabilities are ideal for revealing how stars and planets form for three particular reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can penetrate clouds that are 20 times denser than visible light, which is especially important when observing newborn stars that are hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and image the earliest stages of star formation, when gas and dust are still contracting to give birth to young stars. But there's more to natal stars' clouds than that. Both young stars and giant planets start out as huge, bloated structures that gradually contract over time. As newborn stars get hotter as they age, giant planets cool off, but both emit more light in the infrared spectrum than in visible wavelengths, meaning the Webb telescope will be excellent at finding new stars and planets and helping to understand the physics of their formation. Webb's MIRI instrument will also search for hot molecular gas near numerous young stars, which could indicate the formation of potentially habitable rocky planets. Not surprisingly, a lot of Webb's early science work will focus on determining how planetary systems build molecules that may be crucial to the emergence of life. If you enjoyed the video, don't forget to hit the like button and subscribe to the channel to stay alerted about new videos.